All right, we'll move right on into chapter 5, first section of chapter 5, where you're going to start talking about graphing on a coordinate axis and functions and what are functions and things like that. So let us move forward. Here are the things we will be looking at today. And in this section, just a quick review of plotting points in the rectangular coordinate system. Talk about graphing equations on a coordinate system. We're talking about the coordinate system. We're talking about an X and Y axis, two-dimensional. We're going to talk about function notation. We're going to talk about graphing functions, using the vertical line test to test for functions, and be able to look at a graph of a function and determine things about that. So this should be quick review right here. Here is our coordinate axis, right? It's basically two number lines. That's all we've done so far is dealing with number lines, but the coordinate axis has an x-axis and a y-axis, which are just basically two number lines crossing over each other in a 90-degree angle at 0 on each one. Your positive on the x-axis, your x-axis goes left and right. Positives go to the right, negatives go to the left. The vertical axis is the y-axis. Positives go up, negatives go down. Right? Where they cross there at the center at 0, 0 is the origin. And then you have been taught the quadrants before. The first quadrant is upper right, and it moves around counterclockwise, second, third, and fourth quadrants. All right, so each point in a rectangular coordinate system corresponds to an ordered pair. So we put our ordered pairs within parentheses, the two numbers separated by the comma. The x coordinate comes first, the y coordinate comes second, right there in alphabetical order. So if we have the ordered pairs, -5, 3, and 3, -5, these represent 2 points on our coordinate axis. The first number tells us where to go along the x-axis. The second number tells us to go along the y-axis, and that intersection of those two is the point. So -5, 3, notice they went back 5 and up 3 to there. And for 3, -5, then the x, we go +3 and go down to -5 right there. So there's your 2 points from here and here. Right? The first number is the x coordinate. The second number is the y coordinate. Okay. I think that's something we all should have a pretty good idea about. Let's see if I can. All right, so here is just another quick review of plotting points. Notice one thing to note, that points are named with capital letters. So if you see a capital letter on a graph, that is naming a specific point. -3, 5, -3, +5, 2, +2, -4 is down here. Points that are on the x or y axis is going to have a 0 for either the x or y coordinate. Notice 5, 0 means I go out to 5 on the x-axis, and then I go up or down 0. So right there on the x-axis is that point, -5, -3 down here in quadrant 2 or quadrant 3, and then 0, 4 is a point on the y-axis, over 0, up 4 puts us right there. Okay, so I think we should not have a problem with that. Now, when we talk about everything we've talked about up until now has only dealt with one variable in our equation. Okay. When we were solving an equation, we were solving for one variable. Well, now we're going to look at more of what are actual linear equations, which means they're going to have two variables. Usually an x and a y, but it could be any two variables. So here's an example of an equation in two variables. Notice there's a y and there's x. This one is solved for y. We could solve it for x if we wanted to, but this one is solved for y, which means the y is by itself. And then to get a solution, what this does is this leads to many, many solutions, actually an infinite number of solutions because what a solution is now is it's an ordered pair. It's an X along with a Y that would make this a true statement. Okay, and the easiest way, especially when it's already solved for Y, the easiest way to find solutions is to substitute in numbers for the X, calculate it, and find the Y that goes along with that X. So if I wanted to put in 0 for X, and I wanted to find a point that's on this line or something that makes this true, if I plug in 0 for X, I would have 4 minus 0, which is 4, and I would have Y equals 4. So I know that 0, 4 is a single solution to this equation. Like I said, I could keep doing that. I could put numbers in for X forever and continue and continue and continue to keep getting different points that are on this line or this curve or this graph or however you want to look at it. Okay. What's it say? The graph of an equation in two variables is a set of all points whose coordinates satisfy the equation. All right, so if I were to draw the graph of whatever this is, the graph represents all the points that make this true. It represents all these points, okay? All right, so one way to draw a graph given an equation is to do what we just said. Substitute or pick points for X and come up with several ordered pairs so that you can put the dots and then you connect the dots with a smooth line. All right. So notice in this case, they chose 7 different values of X to substitute in, starting with -3, -2, -1, 0, 1, 2, and 3. When they plugged all these numbers in, here are the outputs or the results they got for the Y that's associated with that X. So if you'll notice, there's 7 ordered pairs. That's obviously I could keep going forever, but if 7 points should give us an idea of what this graph looks like. But here are the ordered pairs. So what I would then do is I would go to the graph, which should be on my next slide here, right there, and notice they have graphed the 7 points. All right. And then once you graph the 7 points, basically you play connect the dots. And what you want to do is you want to connect the dots, and you don't want to make any jagged turns. I'm not going to go up and make any jagged turns like that. All right, unless it's something different. You want to make a smooth curve, connect the dots. And this is a form of parabola. Most of what we're going to be looking at right now are going to be lines, straight lines, but there are a few examples where they are not straight lines. But right, what we do, we plugged in values of X, plugged in a value of X, put it into the equation, found that corresponding Y, and then we could put that point on the graph. All right, so that is one way that we can go to graphs. Now, what we're looking at here is the definition of a function. Certain types of equations in two variables are considered to be functions. Some of them are not. If an equation in two variables, we're talking about X and Y, yields precisely one value of Y for each value of X, we say that Y is a function of X. Now, that is some math sort of mumbo jumbo that's a little bit hard to follow as it is written. But what we have
for your participation today.
All right, so what I've done down here is I've put a little easier way to understand what a function is. And this is just sort of plain language. If you listed all the ordered pairs of an equation, so if I listed all the ordered pairs that came from one of these equations, which I can't list them all, but if you did list them all, the X coordinate would be different in all the ordered pairs. So never, if you're listing ordered pairs, 1, 7, 2, 6, 3, 6. I've listed 3 ordered pairs there. Notice the X coordinate is different in all of them. That's what is making it a function. If ever the X coordinate is repeated, then it is not a function. Doesn't matter about the Y. And if we were looking at it graphically, what would we know about X coordinates that are the same? Like if I were to look at this point right here, which is 2, -1. All right, for a point to have the same x coordinate, what's another point with the same x coordinate? Well, let's say 2, 0. They both have the same x coordinate. Notice that point is right there. Now, how are these in relation to each other? Well, points that have the same x coordinate are vertical of each other or directly above and below each other. So another way we could look at it is if we were looking at the graph, we could not have any points that are directly above and below each other. As long as none of them are directly above and below each other, we have a function. This f of x is a way that we indicate that something is a function, or that is called function notation. Y and the f of x are interchangeable. Notice we could write this equation y equals 4 minus x squared, or it can be the y can be replaced with the f of x, and what's going to go in here is whatever variable you're using right there. Sometimes they change up the letters, but whatever's here is there. This is a function of x, or f of x equals that equation. So I could have two ways I could write that equation. This is in function notation. This is not. Obviously, if something is not a function, you cannot write it in function notation. Okay? So here is just an example. This one, the top one is a function, the bottom one is not a function. Notice the x coordinate is different on all of these, so this is considered a function. Here, the x coordinate of 1 is repeated, so this one, not a function. Okay? That's an easy way to tell. Okay? Now, most of the time, we're not going to be listing out all the ordered pairs. A lot of times, it's just by looking at a graph. All right. All right, so graphing functions. Basically, same thing. If we have the function f of x equals 2x, and we want to look at its graph, okay, what we're going to be doing right now is we are just going to be finding or substituting in values, and I'm going to use 5. I'm going to go from -2. So what I'm going to do is I'm going to substitute in values of x. And the way I write that, if I want to substitute in a value of -2, I write it as what is f of -2? And that means I put -2 in for x, and I get -4. So that point, I substituted in -2, and I got -4. So this right here is a point on that graph. If I want to go, I'm going to go just -2, -1, 0, 1, and 2. So now if I want to know when x is -1, f of -1, that means I go to the right part and I plug in -1 for x. And notice I get -2. So that comes from the point, that ordered pair is going to be -1 is what I inputted in for x, and the y is my output, outputted -2. So -1, -2. If I want to know what's the function value when x is 0, 2 times 0 is 0, so I get 0, 0. And if you'll notice, you should be able to see right now, it is lining up. Of course, I didn't draw this very good. That's what happens when you use your hand to draw things. F of 1, I get 2 times 1 is 2, so that comes from the point x is 1, y is 2. And then f of 2, 2 times 2 equals 4. So when I plugged in 2, I got a y value of 4. And notice, get a line here. I ended up that being a line. All right. I could do the same thing with the g of x. Now notice that's an f and this is a g. The reason they're using g there is because we have two equations on the same page. We're dealing with each other. If we put f of x and f of x, then we don't know exactly which function we're talking about. So they'll change this to a g of x. You see h of x. and things like that. But we would go through and do the same thing for this one, substitute in -2, -1, 0, 1, and 2, and we could get our second line. I'm not going to go ahead and through that. I think we should have that down pretty well. Well, there's our graph I could have used to make things a little straighter, but let's go on. All right, the vertical line test is just simply what we talked about a minute ago. To look at a graph and to test to see if it's a function or not, right? We said for a function, no x-coordinate can be repeated. Well, if 2 points have the same x-coordinate, that means they are vertically in line with each other. Therefore, if I'm looking at a graph and the vertical line test says if I take a vertical line and run it across the graph, at no point does it ever have more than 1 point touching it at a time. Notice this particular vertical line is touching all 4 of those points, so this does not represent a function. Once this vertical line touches my graphed area in more than one spot at any moment in time, it is no longer a function. So here are 4 examples right here of graphs. Now you'll notice right here, if I took a vertical line, I'm touching this graph in 2 spots. There's points directly above and below each other, so this one we know is not a function. This one, no matter where I put a vertical line, it is never going to touch the graph in question more than 1 point at a time. It's only going to have 1 intersection point, no matter where I put that vertical line. So this one is a function. Same thing here. Nowhere when I put a vertical line through is that ever, so this is a function. And then you'll notice that red line, this is the vertical line we're talking about. The blue line there is our graph. There are points directly above and below each other, so we know this is not a function. All right. Vertical line test, pretty simple. All right, now the last thing is just being able to read through a problem and understand what the graph is telling us. So here's an example. All right, and this one's talking about somebody's temperature. All right, so during all this COVID stuff, this is something that's applicable. Do you have a temperature or not, or things like that? So the given graph illustrates the body temperature from 8 a.m. through 3 p.m. So we're talking about a person. Now notice this is hours after 8 a.m. This means that this is 8 a.m., 9, 10, 11, 12, 1, 2, 3. So we end up at 3 p.m. right here, right? That's where it ends up. And on the side is our temperature, right? 98.7 is our actual body temperature. Of course, these thermometers at school usually register less than that, but our actual normal body temperature is 98.6. Okay. Now, here's all we're wanting to be able to do is look at a question and be able to interpret the graph. What's the temperature at 8 a.m.? Well, this was 8 a.m. right here. At 8 a.m., he had 101 temperature. So at this point, we're saying you need to stay home. You have a temperature of 101. Okay. During which period of time is your temperature decreasing? Notice from here to here, the temperature is going down. Each hour, it's a little lower, it's a little lower, it's a little lower. Maybe they took some Tylenol there at 8 a.m. and that caused their temperature to go down and get down to close to normal. So the period of time was from 8, 9, 10, from 8 to 11, right? From 8 to 11. All right. Estimate your minimum temperature during the time period shown. Minimum would be the lowest. So right there, that's the minimum. And it looks like that is right at 98.6. So at what? 8, 9, 10, 11 o'clock, their temperature was normal. They were feeling a little bit better. Thought maybe they were past it, but maybe that was just the Tylenol, because what starts happening then? It starts creeping back up. So let's see what they ask us here. Is it going to clear up for me? There we go. During which period of time is the temperature increasing? So we can see here for these 2 hours, it's going back uphill from 11 to 1, 11 to 1. Their temperature started going back up. So maybe the Tylenol is wearing off. Part of the graph is shown at a horizontal line segment. So they're talking about this part right here. What does that mean when it stays level? What's staying level? Well, at 9, 10, 11, 12, 1, 2, and 3, their temperature stayed the same, right at 100 degrees, right? So that's what it means. It means my temperature is staying the same. When did that occur? From what, 1 to 3. Explain why the graph of y the graph defines y as a function. Why is this considered a function? And this sort of helps explain what a function is too. If, let's say this is at 8, 9, 10, at 11 a.m., you took your temperature. Is there any way you can have two different temperatures at 11 a.m.? If I take your temperature, it's not going to register both 98.6 and 101. I can't have two temperatures at the same time. See, this is what makes it a function, is I cannot have two temperatures at any specific time during it. There's never going to be a point where I have points directly above and below each other. I can only have one point during each hour. I can only have one temperature at each hour during the day. And this is why this is a function. All right, notice that I can have the same temperature numerous times. I can have 100 degrees right here, 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 and here. It's still a function. It only matters that you can't have what's going along, so the x cannot be repeated. Okay, so that's why it is considered a function. And I'll go ahead and activate the assignment, and